స్పీకర్ ఆఫ్ చేస్తుంటాను, ఆన్ చేస్తుంటాను. నేను తింటున్నాను అనుకో, స్పీకర్ ఆఫ్ చేస్తా, ఎందుకంటే శబ్దం.
అసలు స్పీకర్ ఎప్పుడు ఆఫ్ చేసే ఉంచాలి నాన్న, అన్లెస్ మీరు మాట్లాడే తప్పితే ఇక్కడ ఉన్న శబ్దాలన్నీ అవుతాయి, అందరికీ డిస్టర్బెన్స్.
అన్మ్యూట్ అంటే ఆఫ్ చేసా కదా, అన్మ్యూట్ అయ్యి క్రాస్ చేసి దాని కింద అన్మ్యూట్ అని ఉంటుంది. అంటే ఏంటి
అది? క్రాస్ చేసి అన్మ్యూట్ అంటే అది యాక్చువల్లీ మనం మాట్లాడేది వినిపించట్లేదు. అది మైక్రోఫోనా? సింబల్ తెలుసా మైక్రోఫోన్? దాని మీద క్రాస్ ఉంటే ఏంటి అర్థం?
అదే అంటలేదని.
ఎగ్జాక్ట్లీ. దాని మీద కట్ అంటుకుంటే అది రెడ్ మీద పోతే మీరు అట్లా ఎవ్వరు ఏ మీటింగ్ లో పెట్టుకోరు. అది మిగతా అందరికి చాలా తలనొప్పి.
అదేలే. Good afternoon, sir. Good evening, sir.
Hello, voice is audible?
Audible, sir.
Okay, sir. Thank you, sir. Today's strength is very less. Okay, anyway, we will continue the session. I'm sharing the screen. Okay. Now, Unit 4, I will discuss in the next class in the duality in the linear programming and the dual simplex method. How do we solve? We can be discussed today. And what is the before unit means? It is a revised simplex method. We have some modifications finding of the solution. Then that how we can be find out that is a solution. So we can check it in the next class. Here, duality and premial. What is a premial means? It is a given linear programming problem is called as a premial. This is a premial problem. How do we convert into the dual programming problem? That is only the concept. Here, dual linear programming problem. Here, when do we convert? Why we should convert? What is the need of that conversion of this linear duality? These are the things that we have to identify here. According to that, it is economically how much growth we have that we can be discussed in this concept. This is only overall idea about it. How we can be find out that is the best optimal solution. Next, in this duality, here, what I mentioned that all things will come under the introduction part. Your aim is it is appropriate significance and advantages of the duality and formulation of the actual premium linear programming problem. How do we convert it to the dual linear programming problem? How do we convert the dual linear programming problem? Here, when do we convert it to the dual into the linear premium problem also? That is only the conversions into the one. It is a dual to premium and premium to dual. It is a premium means it is a given linear programming problem is called as a dual linear programming problem. That is a given linear programming problem is called as a premium linear programming problem. That premium linear programming problem, if we convert it to the dual linear programming problem, what are the constraints? What are the relationships we have to be maintained between that is a premium and a dual? We should be identified. That is a main objective and main aim of the concept in this unit. Next, establishment of few standard results on the duality. Here, what are some standard results? This is we can identify that is the best optimal solution. What is the way of the results we are getting? That is, we can be check it in this establishment in a few of standard results we can discuss. Next, to give the economical interpretation of the dual variables. Here, economical interpretation means it is always it is a growth point of view. Only we will think about it. It is a business means it is a growth only. If we have a growth, then business can be success. Otherwise, it's a business can be collapse. That is only the two things. So that it is a business. It is a totally collapse. So what purpose? It is money is more. No, money is less. So that it is a decrease. That is kind of the business related as applications we can think about it economically. So that it is used as economic interpretation on the dual variables. How it will be involved. That we can check it in the fifth aim and objectives. Next, the sixth one comes to it is the advantage of duality in the linear programming problem and a dual simplex method over the usual simplex method. How it will be, we have that we can be checking it here. This is the overall idea. What is the duality and premium linear programming problem? In the dual general double it is a, what is the dual meanings? It is a 1 or 2. 1 or 2. That is a word. 2 means it is dual. 2 means dual. Dual means it is a premial and dual. Both are the will be the same results only it will give. But is a decision point of view analysis only, it will be effect on the duality. Decision point of view analysis only affects on the duality. So that it is a best effect means it is the best advantages we can apply on that analysis so that we can get that more profits. It is a less time we can do that is a results we can pick a results. That is the advantage of the duality. Next, it is an industry point of view. Useful industry and managerial decision making point of view. Mostly we will use in this duality. When the premium is fail, here some cases it is a unbounded solutions we can give it. Unbounded cases also I want the solution. Solution does not get also such situations I want the solution. Such cases we can implement that is this kind of the duality. And it is another is main important is competitors are the when it is involved such cases. And most of the examples are the game theory. In that also it is involved the duality opponents problems is more. Next, it comes to the linear programming problem. It is a duality implies it is a linear programming by analyzing into the two different ways. It is both give that is the equivalent solution. But is only the constraints will be the modified into another way of the constraints. Linear programming problem. That is the utilization distribution between the both of the two problems will be the same, premium and dual. So here that is the observation. The original problem is called as a premium problem. And a newly constructed problem is called as a dual programming problem. This is only the just I have given to them. Next is our premium to dual conversion. Yes, it is possible. Dual to premium conversion, it is possible. So, but it's both the solutions will give that is the same answer. So, how do we convert? It is when it is a complicated number of times, it is a time factor is a we think that is a quickly. Even though we will wait for that somewhere, where it is in the getting of the ration or getting of that purchasing the some goods, and we are visiting that is a purchase that is a places. It is every time we will think about that is a time. Here 1 hour time will be there. Can we complete the task in that area? Like that is we will think. So that is a time complexity, beneficials, everything we can be utilized by using that is a dual linear programming problem. Because of premium, when it is a premium, it will take that is a lot of time. At the time, if we apply the dual, we can complete that. Duality more clear. It is a diet problem. Basically, it is a diet problem. So because of it is a diet, it is a small problem. We can use anyone. It is a premium or dual. It doesn't matter. But it's a conversion. If you know that it is a, we can see take up into the duality to the premium and premium to the dual. That is the only advantages of the concept here. Now let us consider that is the case of the producer manufacturing two food stuffs. If I take F1 and F2, two foodstuffs I am taking, both containing the two vitamins, that is V1 and V2. The amount of the vitamin present in each food stuff, the minimum daily requirements of the both the vitamins, the cost per the unit for the two foods are the given in the following table. Now the problem is to determine that is a quantities of F1 and F2. The minimum daily requirements of the two vitamins is met, and at the same time the cost of the purchasing these quantities of the food stuffs and F1 and F2 is the minimum. So from the given table, if you observe there is a two foodstuffs he has given F1 and F2. So I'm taking the F1 and F2. And the daily requirements also we have. The daily requirements also I am taking the units. It is for the vitamin 1 and vitamin 2. The vitamin 1 and vitamin 2, vitamin 1 is taking of the food, I can get that is some quantity of the energy in our body. It is a stuff that is comes to the here V1 vitamin. That is a daily requirement, so we can take that is a less than or equal to 100. Next, otherwise it is equal to 100. Next, it is a vitamin 2. It is a daily needs. It is required for that. It is a F1. F1 is equal to 7 and F2 equal to 12. So that is a daily requirement is a 120. Now it is a cost per the unit is a 12 and 80. It will get 12 and 20. It comes to the maximization. So it is a last discussions, first class discussions. We discussed that is a given theoretical problem, any physical problem. That problem I want to be converted to the mathematical problem. The conversion of the mathematical problem To formulate the problem into the mathematical, let xj, j equal to 1 to so on, m. So already here we have only 2, so that it is x1 and x2 only I can take. The units of the food is purchased. So that is determining the real variables of the x1 and x2. So it is a minimize the cost function z equal to 12x1 plus 20x2. That is the objective function. Here he want to minimize, so that it is a question. The question only f1, f2, so that the minimized requirement, so that it is a minimized plus. Next, since it is a he mentioned that is a daily requirement is a minimum we should maintain, that is a daily requirement, so that it is a more than that we can be maintained from the midterm 1 and midterm 2, so that it is we can go ahead for that 6x1 plus 8x2 is greater than or equal to 100, and 7x1 plus 12x2 is greater than or equal to 120, and x1 comma x2 greater than or equal to 0. It is a clearly we have a picture. The theoretical problem we convert into the mathematical problem. So the mathematical problem is minimization z equal to 12x1 plus 20x2, and subject to the constraint 6x1 plus 8x2 is greater than or equal to 100, and 1x1 plus 12x2 is greater than or equal to 120, and x1 comma x2 is greater than or equal to 0. Here in the construction of the two constraints, it is assumed that any intake of the more than the minimum requirement is not harmful to the consumer. So actually we shall now consider this other problems, real problems. Yes, here anyway here given that is a problem is a premium problem. Now I want to convert the dual problem. How do we convert if you know, then automatically it is a size is increases, a number of variables are increases, number of constants are increases. Such all the cases we can be, premium can be helpful to the conversion to the dual. That is a dual will give that is a quicker solution. That is advantageous. We can check it in these problems. So here I am taking that is a given problem is minimization z, and constraints are the 6x1 plus 8x2 greater than or equal to 100, and 7x1 plus 12x2 is greater than or equal to 120, and x1 comma x2 greater than or equal to 0. Next, it is a minimization z. I will convert it the maximization. It means that is a premium problem is a minimization z. It is a dual problem. Automatically, it will be converted into the maximization z. Next, constraints. It is a variable coefficients are they will be converted as a constraints, and what is the right side is a matrix. B matrix will be there. That B matrix automatically will be enter into the coefficients of the objective function. Coefficients of the objective function. Such a way it is we can be converted the premium to dual. That is a kind of the relationship we can be here. That relationships based on that we can is a total problem is converted the dual linear programming problem. After that we can enter into the generalization. So here first I am taking the one example now. That example I will explain on board. 1 second. Okay, now coming to the issue. If I go ahead for that, it is a food quantities. Here V1 equal to. Here this is I'm writing on the board. Now you can see here vitamin 1 and vitamin 2 and yes, this is a 6, 8 and 7, 12. This is 100 and 120. As per that is a minimization, it is a 12 and 20 has. This is a cost. This is a given problem. In this given problem, actually linear programming problem, we can write as here introducing that is a variables. What happens here? Introducing the variables, it is a 6x1 plus 8x2 is greater than or equal to 100 is one constant, and 7x1 plus and 12x2 is greater than or equal to 120. Now it is the restrictions are the x1 comma x2 greater than or equal to 0. And the maximization z or minimization z. Already question in the mention that is a minimization. Minimization z equal to here 12x1 plus 20x2. Now in this problem, here 12x1 plus 20x2. Now here this is called as a primal problem. Now I want to convert it to the dual problem. Now converting into the dual problem. The converting into the dual problem, I will take that is these are the first. This is a y1. This is y2. Okay. Here, objective function coefficients. This is the objective function coefficients, or these are the line. So here, this is a x1. No, here x1 I will compare. Here, conversion of that, it is a minimization will be converted into the maximization. Maximization z equal to. Maximization z equal to. Objective function we should take. 10x1, 10y1 plus 120y2. So this is y1. This is y2. So 100y1 plus 120y2 is the objective function. It means that is a constant only, it will be converted to the objective function. Next year, coming to the here y1 means it is a C here. What we can take here? Here, y1, 6y1 constants. Here 6y1 plus 7y2 less than, greater than or equal to will be converted to the less than or equal to 12. All x1s I am taking. 6y1 plus 7y2 less than or greater than or equal to constants will be there now, so that it will be converted to the less than or equal to 12. Similarly here 8y1 plus 12y2 less than or equal to, this is x2 only, no? So x2 coefficients, it is a what? 20. Next to, this is y2. y1 comma y2 is greater than or equal to 0. y1 comma y2 is greater than or equal to 0. Once again, listen here. How I converted to the given linear programming problem into the dual. So here given problem is a 6x1. Here this is a 6x1. This is row-wise. It is a when we have taken, and cost is a have taken. This is comes to the row-wise when we will use. At that time, this is comes to the primal problem. When I want to convert it to the columns wise, see here, I have taken the columns wise. Columns wise means it is a 6. This is y1 and y2. So what happens? It is a 6 now. 6y1 plus 7y2 is again it is less than or equal to 12 because of greater than or equal to constants. It changes to the less than or equal to. So here y1 plus 6y1 plus 7 less than or equal to 12. And here 8y1 plus 12y2 is less than or equal to 20. Next objective function is 100y1 plus 120y2. It is clearly is a maximization set. So it is a basic matrix is What is that is a basic solutions we have that is comes to the objective function coefficients. So this kind of the conversion is called as a premial to the dual problem. What I did, you should be mentioned that it's a problem. A premial and a dual. What is the premial we have? If it is a minimization will be there, it will be converted to the maximization. If it is a maximization will be there, it will be converted to the minimization objectives. Objectives will be converted. Minimization is a maximization. Maximization is converted to the minimization. So here, maximization is converted to the minimization, converted to the maximization, and maximization converted to the minimization in the dual. Second is comes to the constraints. Yes, thesis. Subject to the constraints, it is a greater than or equal to. Greater than or equal to will be converted into the less than or equal to, and less than or equal to converted into the greater than or equal to will be the equal to one. After converting it into that, your objective function, one more thing you should be remember. What is it? It is a matrix B. Basis coefficients. Basis is are converted into objective coefficients in the dual. Objective coefficients in the dual. So here it is the constraints are converted to greater than is less than or equal, less than or equal to, greater than or equal to, and equal to equal to. It is good. Now coming to that is another it is a rows. Rows will be converted to the rows will be taken into the premium, and column will be converted into the dual. This is only the difference between both of them can be identified, that is premium to dual. Then dual for simplex method we can premium simplex method we apply. Procedure is the same. We can obtain that is a same optimal solution. This is the overall idea about it, how we can solve that is a problem. Now coming to that, in this problem, if I observe, yes, objective function is 100. So 100 W1. Next 120 W2. It means that here we are taking that is only 100 and 120. 100 and 120. So here is taking the W1 and W2. 100 W plus 120 W2. We are able to see minimum. The minimization Z is converted to the maximization Z. Then x1 plus 8x2 will be 6x1 plus 7x2 now. So 6W1 plus 7W2 is less than or equal to 2x1. So that less than or equal to. So greater than or equal to constraints can be converted to less than or equal to. Then here, second x2 coefficients are 8W2, 8W1, sorry, plus 12W2 is less than or equal to 3. So this is comes to the W1, W2 is greater than or equal to 0 is called as a maximization Z and minimization Z converted. So here it is clearly premium problem is connected to the. We can identify that is a simplex procedure. We can get that is the best optimal solution. This is overall idea. Now coming to that, the restriction. Procedure is also the taking given given. So maximization Z means it will convert to the minimization Z. So Zx equal to C1 Xn and A1 to C1 to A1 in Xn is not equal to B1. A2 plus A2 X2 plus 1, A2 and Xn is less than or equal to B2. So on AM1 X1 plus AM2 X2, so on plus AMN Xn is less than or equal to BM. And X1, X2, so on, X are greater than or equal to 0. To formulate the real form into the from the given linear premium form. So now the dual programming problem gives the dual problem from the given problem. Adapt these are the conditions. What I mentioned about It is clearly, it is we are mentioned here. Premier problem with the n variables and m constraints. What are the variables? x1, x1, xn, all are variables. What are the variables? x1, x2, so on, xn, all are the variables. We can see that x1, x2, all are the n variables. And how many constraints means it is less than or equal to how many we have b1, b2, b3, so on. So m constraints and n variables, x1, x2, so on, xn variables. Now dual problem will have that is m variables, n constraints. That is a given problem. Greater than or equal to inequality in the premier problem is become the less than or equal to sign of the dual problem. Greater than or equal to when we have in the premier, it will be converted into the greater less than or equal to in the dual. Next, less than or equal to inequality also get there is a revised greater than or equal to type. Maximization objective premier can be converted to the minimization z into the dual problem. The constraints is the objective function premier problems will be the b1, b2, bm is the constants of the inequality of the problem. Next, the constants of b1, b2. So if b1 is a constant, inequality in the premier problem become that is a c1, c2, cm, the objective function of the dual problem. Then it is the last one is in the both the premier and dual problems. The decision variables are non. So this is comes to the how to convert the premier to the dual problem. Next, maximization z w1 I am taking and y1, y2, so on, y1 variables. So here objective function goes to the here right side. What we have b1 w1 plus b2 w2, so on, m wm. Next, here variables we have number of constraints it can be converted. This is overall idea about that's a premier to the dual conversion. Now, if I go for that is a maximization z in the premier, automatically dual is goes to the minimization z. If it is a minimization z, if I take in the premier, then it is a maximization z in the dual problem. So that it is a minimum will be converted to the maximum and maximum will be converted to the minimum. Subject to the constant less than or equal to will be converted, then or equal to greater than or equal to can be converted to less than or equal to. Now I am taking one example for the right into the dual form. Dual form means it is an objective function. See here 1 w1 or 1 y1. First objective function I am writing. All are less than or equal to. All are positive only, so that no issue. 10y1 plus 2y2 plus 6y3 is the minimization. The maximization z is converted to the minimum. So this is objective function. Sorry, objective function. Next, constraints will be go for. Constraints will be go for. Is a y1. Here x1 coefficient is a y1 and 2x1 is a 2y2 and 2x1 is a 2y3 is greater than or equal to. Here x1 objective function, previous objective function coefficient is a 1, so greater than or equal to 1. Here less than or equal to inequality will be converted to greater than or equal to 1. Next, here continuation, that is a second variable. If I check, here x2 will be there in the first constant, but is x2 is not there in the second constant. And the third variable, here x2 will be minus 2. So that it is, if I take all the constants, I will get that the answer is here 2y1 plus 2y2 minus 2y3 plus y2 minus y3 equal to 0. Then it is a corresponding that here now here second constant x2 is not there, so that there we will be take that is a 0. So here y1 plus 2y2 plus 2y3 is greater than or equal, less than or equal to can be converted to greater than or equal. And y1 plus 2y2, here middle part I am taking y1 plus 2y2 plus y2, not 2y3 plus y2 minus y3, it is greater than or equal to 0. So that like here we can convert into the inequality to premier to the dual problem. Next, to dual conversion, I am taking another example. When we have a equal to also, it is a greater than or equal to will be converted to the less than or equal to, less than or equal to can be converted into the greater than or equal to. This is the overall idea. Now coming to the another objective function, maximization z. I am taking another linear programming problem. It's a dual problem is converted into the same. Some standard theorems on the duality. Some standard theorems on the duality is important. Dual of the dual problem, programming problem is the premium. Dual of the dual. Here first I applied that is a premium problem to the dual. Again dual to dual, if I convert, automatically it will be converted to the premium. So here premium problem in the canonical form is a minimization z equal to zx equal to cx. Zx equal to cx. Next, it is a subject to the constraints. I am taking Ax is greater than or equal to B because of minimization Z. So it is a m by m coefficients matrix. So B transpose is belongs to A as e power m, and C comma x power transpose belongs to e power m. Then rule for that is a maximization Z is a automatically y will convert now minimization I will convert to the maximization Z. If we convert it to the minimization Z, nobody consider it is a objective function. Now it is a B transpose belongs to e power m, and C comma x power t belongs to e power m. Next minimization z zy equal to B transpose when A transpose y is less than or equal to C transpose y greater than or equal to 0. So it is a minimization z that will be converted to the maximization z. It is a minus B transpose y. This is called as a generalized problem conversion. So it is a minus A transpose into y equal to minus C transpose. Less than or equal to can be converted to greater than or equal to 0. C power t. So here, which are the variables we can identify then? If I substitute that is a minus C transpose equal to C1. So minus C itself. So it will be clear that it is a linear programming problem. Dual is converted to the primal is converted to the dual problem, and dual again dual to the dual is called as a primal problem. This is the oral idea. Next problem, next theorem. If it is coming to the next theorem, here, if ith constraint in the primal problem is an equality, then the ith dual variable is unrestricted in the sign. So consider the given linear programming problem to the standard form, and minimization z zx equal to cx, and subject to the constraint ax equal to bx greater than or equal to 0, and maximization zx equal to cx, and subject to the constraints it is a ax less than or equal to b minus a into x is less than or equal to minus bx greater than or equal to 0. Maximization z means minimization z conversion. Here z y equal to y1 into b power b transpose plus y2 into minus b transpose. So y1 minus y2 b transpose. Then we can be apply for that. It is called as a minimum to minimum. Then it is a variables can be expressed into the y equal to y1 minus y2. So it is expression values will can be we called as unrestricted. Unrestricted variables means it is instead of y, we can substitute that is a y1 minus y2. It is a positive and a negative. Both addition, if we substitute, it is called as our required subject to the constraints. Here unrestricted can be converted into the restricted. Next, if the either the primal problem or its dual has an unbounded solution, then the other problem has a no feasible solution. So here to establish his theorem, we prove that lemma it is a limit x star be any feasible solution to the primal problem. Minimization zx equal to cx, and subject to the constraint x is less than or equal to b, and x is greater than or equal to 0, and y star be any feasible solution to its dual problem. So maximize y equal to b transpose y, and subject to the constraint a transpose y is greater than or equal to c transpose, and y greater than or equal to 0. Then show that it is a cx star is less than or equal to B transpose. The B zx is less than or equal to 0. Now this is a proof point of it. This is a lemma. Lemma means it is a theorem. Proof point of it, we can x star is less than or equal to b, so that a transpose y star is greater than or equal to c transpose, and y star is greater than or equal to 0, and c transpose is less than or equal to transpose into y. transpose into X star equal to Y star T into B equal to B transpose Y star. Since Y star T, and then the complete problem is a minimal problem. It is a premial problem when we convert it to the real program problem. It is the optimal solution. In the other problems also possess that is optimal solution. And the optimal values of the objective functions of the two problems are the equal. It is maximization Z is equal to the minimization Z. Next is comes to the xb equal to here B inverse B small b. It is the optimal basic feasible solution to the premial problem. Then CB is the cost is the vector's basis, vector of the basic variables. Then according to that optimality condition, we have Cj minus Zj is then equal to 0. For any vector Aj belongs to A, not contained in the B, then Cj minus Zj is equal to the Cj minus Cb into Xj. So Cj minus Cb into B inverse Aj. So it is a matrix notation, it is equivalence. Similarly, Y star equal to Cb B inverse, if I take then C is less than or equal to Cb into B inverse A. That implies it is a Y star A or C transpose is less than or equal to Y star A transpose. Hence, it is a Y star is a feasible solution to the dual of the given premium, since it is satisfies the dual constraints. The corresponding dual objective function is given by the Z Y equal to Y star B transpose equal to, then we can continue that is a Z Y equal to Y star B transpose equal to CB into B inverse, B transpose equal to CB into X equal to ZX equal to, then it is comes to the, it is a CB into B inverse is a feasible solution of the premial and the dual, both are the same. Here maximization Z we can calculate in the premial and minimization Z we can calculate into the dual. Next, it is a complementary slackness is we can be checked. It is also the proof of the problem. We can introduce it as a some variable, then it is a make the equal. Then it is a minimization Z we can be subtract some variable, then it will be making into the equal. So it is a premial, it is a, we will take that as X star and a feasible solution. And dual is take that as a Y star, it is a feasible solution. So that it is a maximization Z will be the top and minimization Z is into the two bottom, it is will be go to the two. So multiplying the constants of 1 by the yi, I equal to 1 to so on m, and then add to you get that is xj is summation of a is a yj yi plus xm plus 1 yi equal to summation I equal to 1 to m yi into bj. So this is a original objective function will be converted into the our required real objective function, and constants are those slack variables will be converted to the surface variables. Then it is multiplying the constants yi, so that automatically it will be converted to the equation number 3 and equation number 4. Then equation number 4 both all will be the subtraction. It will take that is both of them. We can get that is the minus summation xj into ym plus 1 minus summation yi xn plus j equal to zx minus xj. So that it is optimal solution. Both cases are the same, zx equal to xy. So this is important theorem for that. It is a complete complementary slackness theorem. Complementary slackness theorem. Then similarly, we can apply that. It is a summation xj and ym plus 1 j. It is a summation yi xn plus 1 equal to 0. And then the each of xj is greater than 0. And similarly, ym plus 1 equal to 0. Then we can obtain that. It is a first equation is a summation aij yi is equal to ci. And similarly, it is a when ym plus 1 is a m plus I is equal to the 0, then summation aij is x yi is greater than cj. Now similarly we can proceed further other constraints also, such a way premial will be converted to the dual problem. And a duality simplex. Hello?
Somebody is asking to, he wants to join or somebody.
Okay. Actually, control is not in my hands. Once again, I will check. Actually, it is in the university control.
So, okay.
Okay. Now we can't help him.
So, okay.
Next, dual and the simplex method. Duality in the simplex method. How do we solve? Same, we can apply. That is a primary problem. This one, and this is converted to the problem. Already I said it is a what is a. These are the 3 and 5. 3 and 5. 3 and 5. Here I will show that. Here this is a, my cursor is showing here. 3 and 5. This is a 3 and 5. So this is 3 and 5 is a 3y1 and 5y2. This is called as an objective function. This is this column coefficient is a B matrix goes to the objective function as a minimization can be converted to the minimization. It is a ZX is this one, but it's a ZY is goes to the here 3 and y. It is a constant coefficient. It's the right side. What we have a constant matrix that will be go for the objective coefficients, objective function coefficients. Next, it is a similarly, I will take this is y1, y2. So that is a 2y1 plus 8y2. 2 say y2. It is less than or equal to will be converted to greater than or equal to 40. Because of all x1 coefficients will be we can take here. Next to all x2s. It will go for that is a 3y1 plus 4y2 is greater than or equal to 50 because of less than or equal to all. For y1, y2 greater than or equal to 0. Then it is already less than or equal to means only slack I will introduce. It will be converted to the greater than or equal to surplus I will use. So minus y3 plus y5, minus y4 plus y6. Here I will use the big M method. I will use that is a simplex method. From the both simplifications, I can get that is a same answer. That we can see here. This is called as a premier problem, left side. Same procedure. I apply for that is a two-phase method if I apply for this because of either two-phase method or you can apply the big M method. So here two-phase method if I apply, right side it will be the converted into the phase 1 and it is goes to the phase 2. So that I will get that the both answers are the same. What is that 51.25? Just it is a simplex. It is the slack variables I introduced and I identify the solution. Yesterday I explained that is simplex procedure. Same way, if I try, I will get this is the answer. 51.25. It is if I apply that is a dual, it is also I will get that is a 51.25. So this is a premier and a dual information. How we can be check it. Procedure is the same simplex method. Here this is a slack variables are introduced in the premier. We can apply for that is a premier general simplex method. Here, when we have a greater than or equal to, then we can apply for that is a question is comes to the dual linear programming problem. There you should be apply that. Either big M method or two-phase method. Here, big M method I'm applying, I'm getting that is either two-phase method here I'm applying, I'm getting the same answer. Already in our textbook you can solve it. Next, economic interpretations. Hello, sir.
Sorry, in dual, he has applied for artificial variables also, he has introduced that.
Yes, sir. So here for artificial variables also introduced. Instead of A, sir, instead of A1, he introduced the Y5, sir.
Yes, sir. Y5, Y6. Oh, sir. Thanks, sir.
Y5. Here Y6 are artificials.
Thanks, sir. Thank you, sir.
Now, here this is the original procedure. Next, economical interpretation of the dual variables and dual constants. It's the theoretical, they may ask the question. What is that? It is X is the number of units for the variable, and the projection of the return to the unit cost is a CJ, maximum units for the resources, and the AJ is the units of the resources I consume and returns to the profit. So this is the overall idea what we have, that is economical conditions. Economical, what are the variables? Here, premier problem as per the economics. It is a maximum returns we are expecting, that is called as the objective function. Next is subject to the constraints, so unit resources. How I should be utilized? It is the lesser amount. That is comes to the subject to the constraint. This one up to here. Next, it is the xj is greater than or equal to 0. Similarly, it is if you apply that is a dual problem, it is maximization z is comes to the minimization z. It is a maximum return I am expecting. Here I am going for there is a premium is a minimum expenditure I am expecting. So here that is a returns I want or cost I want to reduce. Which one you can be? The situation is both cases are the same. So that it is a I will check by dual and I will check by the premium. Both the cases it is a be the same. So that it is a according to that I will act as a in the company employees or project whichever we want to be applied. On that I will put a pressure and I will complete my task. That is a economically it will do that is a growth. So that is a premium and a dual. Both they will check. From that it is a what is a premium? Premium it is goes to the returns maximum profit of the returns I will expect. It is a dual goes to the minimum expenditure they want to be check it. It means that is a totally depends on the resources. Here it totally depends on that is all the resources, but it is based on the profit we will check. Here all the resources, but it is a minimum cost we want to be applied. So this is only the difference between the premium and dual. We can apply that is a premium and corresponding that is a dual. So we can get that is a physical problems like convert into mathematical problem. We can solve by using that is a simplex method. Next, coming to the it is a firm manufacturers two products A and B on the mission 1 and mission 2 shows below. It is a mission 1 and mission 2. It is a product and a product. So it is the average time. Here premium problem given problem is a premium problem. Then I am converting to the dual problem. Here objective function minimization converted to the minimization. Here constraints it is a 30, 300 and 110. So that is a 300 by 1 plus 100, 110 by 2. Then it is a 30 by 1 and 5 by 2 is greater than or equal to 6. And 20 by 1 plus 10 by 2 is greater than or equal to 8. By 1 by come by 2 greater than or equal to 0. Such a way optimal solutions I can identify, we can get that is the best optimal solution. Either applying that is a premium or dual, both solutions we can get the same. The dual simplex method is also clearly followed. That is the same simplex procedure. Here greater than or equal to will be there. Inequalities we apply that is the artificial variable, surplus and artificial variable. So artificial in the two-phase method, if you apply first artificials, we will remove. Then that is phase 1 and phase 2. It comes to the what are the solution we got it. That solution in that A1 A2 we remove and apply the same matrix values and the objective functions, so coefficients we will take. Then we can apply that is a solution procedure by the simplex. So we can get that is the same solutions. This is a dual. So here two-phase method also we can apply. Here bigger method also we can apply. Next, it is a computational procedure of the dual simplex method. It is the same. Ratio is the same. Delta J first I will calculate Zj minus Cj. All Cj's are less than or equal to 0. Then it is comes to the minimization Z xb by xj. Then maximization delta J Zj by the Cj greater than or equal to 0. This gives that is the best optimal solution. If it is less than or equal to 0, it is a we need to go for that as a next solution. Otherwise, it is unbounded, so that solution does not exist. We can declare. This is the same procedure I can be applied. First iteration and second iteration, I got it the solution. Advantages of the dual simplex method. It is a many times it is advantageous. So called that is a say dual of the premium problem that has a less time, less number of constraints we have. Here, the number of constraints are the more. At the time it is take there is a lot of time. The time consuming reduction point of view, it is a columns we can be changed, reduced into the rows. Such a way we can be minimize the total number of constraints so that we can get there is a quicker solution. Here, dual variables provide there is an importance economic interpretation for the final solution. That is one more reason. The main advantage of the dual simplex method is over the user simplex method is we do not require any surplus and artificial variables to introduce there is a dual simplex method. Then saved a lot of computations of the labels. Next is the dual simplex method can be used for the solve the linear programming problem. Initial solution is infeasible but optimal. And in the economics and duality is Economics duality is useful to the formulation of input and output system. It is also useful in several problems of the engineering management. This is the overall idea about that. Is a total theory part about in the linear program. Dual to the linear problem, or premium to the dual problem. So here theorems we have, theorems you should be followed. Here last class your one of the friend asked that sir examples you can solve. But the same procedure you should try. Then you send to my WhatsApp number. That is only the verification point of view. This is overall idea.
Sir. Okay, sir.
This is a totally called as a duality in the linear programming problem and a dual simplex method. Okay. In the next class, I will continue. That is another short topic. Here, what are the topics we have? Once I will show you. The third topic already I completed. Method and two-phase method in the last class. Next to fourth class is the post-optimal cell sensitivity analysis will be there and revised simplex method. Here revised simplex method standard form 1 and standard form 2 and sensitivity. That is a total general concept only, theoretical concept only. One problem we can discuss in the next class. Next, here, if it is there in possibility, you can leave this question in the choice. So, I have given that is a duality and a premial. You will give one problem so that I explain clearly. Here, you should be attempt mandatory examination. Premial to dual, dual to premial conversion, and solving of the problem also you will get the same solution. And theorems also, few theorems we have, and once you hit, you can get that is a solution. The theorems 5 to 6 theorems will be there. You thoroughly prepare. And users also learn it. And this problem also you should learn that is a premial to dual conversion and dual to premial conversion. And optimal solution also, how you can do it and you can get the solutions. Next, it is economic interpretations also I explained. Generally, you can discuss and you can discuss that is a premial and dual problems. These are the mode. At the time, we can convert it to the dual to the premial to the dual. Dual simplex, how we can solve this, I explain, and various examples I have given to you. This is the overall idea, premial to dual problem. Next is sixth unit is integer linear programming problem. It is also important. One question you will ask in the examination. I will try to explain in the next class. Next, another unit will come to the 7. It is a transportation problem. Assignment problem, routing problems. Next chapter. We will discuss afterwards. Okay. This is the overall idea. Okay. Next class we will discuss the thoroughly other chapters. Okay. Okay. I will wind up the session today. Thank you. Thank you very much, everyone.
Thank you, sir.
Thank you, sir. Any more doubts?
No, sir.
Okay. Thank you. We will meet in the next class.